is it. We're starting. Good morning, everyone. I'm Nancy. Thanks, Priscilla. Hello. Thank you, Maura. I'm Nancy. I'm a member of Peters Pond. Thank you. Okay, good morning, everyone. Thanks so much for being here. I want to make sure I'm just going to go down my list. I just want to give you guys some information, and then we're going to pass it off to Shaston, our wonderful host, and Maura and Corey. Okay? So I'm Nancy Horn. I'm one of the co-founders of Friends of Peters Pond with my friend Chris. She's in the back with the sweatshirt. She's making sure a couple more people are coming. And her husband Jeff is here too. He's our board member too, Chief Technical Officer. So that's why he has this on me. We're recording just a few things, so just so you know. Chris and I would like to welcome all of you, members of Ashumet, Mashpee, Wakeby, Peters Pond groups, the town of Mashpee, where are you sitting? There you are, and the Mashpee Wampanoag tribe. Welcome and thank you to Shaston and her team from the Cyanobacteria Monitoring Collaborative and the town of Sandwich for offering the building and the waterfront for our use. We're so grateful that we can all be together here. Couple housekeeping items. Sign-in sheet we already did. Does everybody have a name tag folder and a pen? Hold them up. I want to make sure. I'm just kidding. I used to teach middle school, so I'm like, if you move at all, you're ready to give a comment. So don't raise your hand if you don't want me to call on you. Restroom is right up here. It's a uni. So if you need a restroom, another one, just go on down. There's a larger building down behind us called the Lodge. When you walk in, it's going to be to your right. Just keep going to your right and you'll see there's another restroom. There's also water refills. If everybody brought a water bottle and you need more water, they have, an urn that you can go in and refill over there if you need to. There's going to be a photographer coming from the Sandwich Enterprise. Did everybody see that article last week about our training, which was wonderful? So they're sending a photographer. They're going to be here around 9:45, and they're just going to shoot some pictures. So if you do not want to be photographed, just let them know. I'm not sure who's coming, or I don't know their name, but if you don't want to be photographed, just let them know, okay? That's your choice. Also, we're going to be doing a little bit of filming, and so if you do not want to be filmed or you don't want to be in a photo, just let us know. I'm going to be the one doing that, so just say, Nancy, no. No. Okay. Right now, I'd like to invite a representative from each group to come up. Just say your pond name, your website, if you have one, your contact information, if anybody wants to get a hold of you, and we have all that information too, and your social media handles. So if someone from Ashumet could come up, Mashpee, Wakeby, if you want to come up and introduce yourself, Sydney, and also from the tribe. Just a couple little sentences.
Hi, my name is Mark Baracco from Friends of Ashumet Pond. We have a Facebook page, Friends of Ashumet Pond, not yet a website, and on contact information, my name, Mark Baracco at AOL.com, and phone number 339-223-9721.
Perfect. So easy. You did it. Okay. If someone could come up from Mashpee, Wakeby, that would be great. It's nice to have all of us together, isn't it?
Yes, it is. I'll take my mask off for a minute, but I got scared that I had COVID a few days ago when I got tested and was negative, so I'm like living with a mask. So anyway,
Got it.
I'm a germaphobe. Anyway, I'm from Mashpee Wakeby Pond Alliance. We were created about a year ago, less than a year ago. Our president is Sue Dangle. There are 3 of us who are here. We started forming our group right after, 4 of us, sorry. So we formed as a group right after the bloom, and the Mashpee Wakeby Pond closed the lake for 2 weeks. And so as a group, we've been trying to bond with other pond groups and also to educate our members to see what we can do about maintaining or changing the quality of water in Mashpee Wakeby Pond, and then to bond with other groups so that we can work for clean water around the Cape. So we're at SaveMashpeeWakebeyPond.org. We have a Facebook page, and we have a webpage.
Wonderful. Thank you so much. Okay, Peter's Pond. That's me. Okay. Peter's Pond. Okay, we are Friends of Peter's Pond. We're brand new. We just formed. We formed because of that bloom that we had on our pond last summer. It was kind of a fiasco. So that is why we decided to form a group. We have a website that is now live thanks to our Chief Technical Officer, Jeff Dennis, woo woo. So it's friendsofpeterspond.org. Also, we have an email that we will be contacting you from now on. So we've been using our personal email. So it will be info@friendsofpeterspond.org. We have a Facebook group, Friends of Peter's Pond, that's a shock. And you can join it. Even if you're not in our pond group, we welcome anyone to join us because we're all learning together. And we do not have Instagram. We're not Instagrammable yet, but we're going to be. Okay, and then come on up. Wonderful.
Hi everyone, I'm Cindy Crook. I'm from the Cyanobacteria Natural Resources. I'm the Shellfish and Water Quality Technician. I'm here today to just really learn a little bit more. I can learn from all of you. And we have a few projects going on in Mashpee to improve water quality right now. We are working with the state with a municipal vulnerability preparedness program to improve water quality in Santuit Pond. We're looking at stormwater retrofits and then looking at potential algae treatment in Santuit Pond. Moving forward, we're going for a second round of funding with the state with the MVP program to put our retrofits into construction and get more designs to permitting and design. And then we also have a diagnostic study going on at Mashpee, which kind of was kickstarted by that cyanobacteria bloom that occurred last summer. And we are getting 3 new water quality devices to deploy in 3 different bodies of water in town. So we're really trying to improve water quality, and I can teach you something and I can learn from you guys. So happy to be here.
We're so glad. Okay, and then Jason, do you want to come up? Thank you so much.
Good morning, Jason Stiting with the Mashpee Wampanoag Tribe. I'm the tribe's Natural Resources Director. I'm here with Gail Oakley, the tribe's Assistant Natural Resources Director. Obviously, you know, like all of you, we are trying to protect our waterways, our natural resources. We're concerned about everything Cape-wide. Never mind just in our local towns. We were just at a meeting in Balfour the other day in Truro on some water quality issues up there. So again, we're here to learn. Gail and I are relatively new to this department. We've been with the tribe for quite a while. We are working with the town. We're a co-applicant on their MVP application, so we're doing a lot of work with the town on Santuit Pond specifically right now. But again, every pond on the Cape, Massachusetts, and even the southern Rhode Island, which is our ancestral territory. Important to us, as I'm sure it is to everyone. We have a website, MashpeeWampanoagTribe.com. We have a webpage on there, Natural Resources. It's not really up to date. We'll get better with that. And we do have a Facebook page too as well, which we try to update pretty frequently. So that's a pretty good place to go if you're looking for any resources. My email's very long, jason.stiting@mwtribe-nsn.gov, but I can write it down for you.
Okay, that's awesome. Okay, guys, I'm just really filled with gratitude today, just that we can all be here and that everybody can come and whatnot. Yes, and support one another. Okay, Friends of Peter's Pond and also each individual pond. Our goal today is to self-identify members of our group who would like to potentially serve on a committee to monitor the pond this first summer. So be thinking as you're going through the training, whether that would be something you're interested in. We're looking for about 8 to 10 people, and we're hoping at the end of our meeting, if you're interested for Peters, come on up to the front and we'll set up a follow-up meeting time to kind of get together and make a plan. Okay? Any questions? Any comments? Concerns? Middle school. Yes, Chris?
What time will we be back here?
Yes.
When this is over, if we're meeting back for closing. So we normally, what we do is we do the presentation or we do the stations.
Yep.
And what we do typically is we just let them run as long as they need to.
Yep.
But we have until February 20.
Yeah, 10:20.
So
It's just until you guys kind of run out of questions. Yeah. So.
Okay. So like noonish?
Yeah.
yeah, I'm not sure. Like,
12, 12:30.
Yeah.
Okay.
We're gonna start meeting back here.
Okay.
And all of us are mostly going to be here. It's just going to be the group that's with Mora.
Yep.
We're going to rotate.
Okay.
So the group that's with Mora, they'll be going to the pond.
Great.
So that will be the group that will be away.
Great. And if you guys, some of you, need to leave because, we said noon. So don't worry, just like come and say goodbye. We'll give you a little hug and then you guys can go. Okay? I'm going to pass it off to Shaston and Jeff's going to help me take this off so I don't break it or drop it or turn it off.
If you end up leaving a little early, we just have a bag full of comic cards. If you could just tell us how we did before you leave. That would be great. Yeah, right by the door. So that is your homework.
Okay. Yep, that's good.
Comment card.
Okay. Thank you.
Yes, that's how we'll do it, because with kilometers, one with the microscopes, and then one with the sampling, it just kind of rotates every day.
Yeah. You're good? Okay. Well, welcome everybody, and my name is Shaston Sherwell. The three of us are with EPA Region 1. And then, do you want to introduce yourself, Corey?
I'm Corey Fondle. I'm a field biologist at the EPA Chelmsford lab. I do a little bit of cyanobacteria work, along with some water quality work as well. I mostly do my work with Mora and Hiller's. Okay, I'm not sure if it's out of the lab as well.
Nora.
And hi everyone, I'm Maura Gould. I also work in water quality and do a lot of real-time monitoring in urban watersheds, working in the Falls and Mystic River, and then doing other water quality work in ponds in the area.
And for me, I am in the Boston office, but I'm also working with Corey, with Mora, and with Hillary in Cyanobacteria. We have this collaborative that is the Cyanobacteria Monitoring Collaborative. And we're going to be talking about that today. And what that is a set of protocols that citizen scientist groups, municipalities, tribes, anybody, public drinking water suppliers can adopt. And it's just a way to monitor cyanobacteria, as well as communicating the health risk, kind of having this outreach of this component of outreach and education too. So we have a lot of videos and stuff like that. So we're going to be talking about that. First, we're going to start with an overview of cyanobacteria, what cyanobacteria are, what blooms are, why do we care, and what causes the blooms. And then we're going to go into the CMC program, and that's the Cyanobacteria Monitoring Collaborative that I talked about. And then we'll do the stations. So as we said, we'll have 3 stations, and we'll rotate through so that everybody has a chance to have hands-on experience with protocols. So cyanobacteria are one of the most ancient organisms in the world. They have one of the oldest fossil records, and even outside of the fossil records, like we know that they have been in this world for a very, very long time, around 3 billion years ago. And this is a picture of the stromatolites in Australia. And those are really, really old. Those are colonies of cyanobacteria. And cyanobacteria had a huge role in the evolution of Earth. They are the first photosynthetic organism. So they're the ones that instead of using hydrogen sulfide, they started using water, the oxygen from that, to fix carbon. So because of them, they produce as their byproduct, they produce a lot of oxygen that in the ocean that eventually gassed off, and that created the atmosphere that we can thrive in. So this is just sort of kind of like a time scale so that you can see how old cyanobacteria are. And the whole point of this slide is to show you that they have a critical role in our environment. And they've always been, well, not always, but they have been here for a very, very long time. And they are found everywhere. We can see them in deserts, in forests, in air, in water, in hydrothermal vents, in Antarctica. Like we see them all around the world. So what are they? They are often called blue-green algae, but they're not really algae. They're bacteria, but they're called algae because they behave like algae, because they are photosynthetic. So if you look at our typical diagram of an algae cell, you can see the chloroplast, you can see the nucleus, you can see all this typical cell, like eukaryotic cell structures, while you see in cyanobacteria, you don't see that much formation. It's just, and that's what tells that it's definitely a bacteria. It's not a eukaryote. The thing that made it be into that algae component was the fact that it photosynthesizes and it's green. So it's kind of like always classified with the algae. They look like this. This is all under the microscope. So they can have many different morphologies. You can sometimes see something like this, where it's just like a little string or like a pearl necklace. That's what I like to think about when I see this kind of stuff. But you can also see it more in colonies. They can be small colonies, or they can be big colonies like this. Then they can form even bigger colonies that look like hairs. So they have different morphologies. The different genera look very different. But there are some key features that we want to show you how to look for those, and those are the acne and the heterocyst. And you will probably see those today when we do the microscope station, and we can talk more about them and how to really identify them. So as I mentioned before, cyanobacteria can be many different types. They can be unicellular, they could be colonial, they could be multicellular filamentous. And they can also be less than 2 microns in size. And those are the Picocyanobacteria. And those are very hard to see while you're monitoring your water, because you can't see those with the regular microscope. And we'll talk about what are the different tools that you can use in order to catch those, or to capture those Picocyanos as well. These are some examples of the common genera that we see, cyanobacteria genera that we see. Anabina dolichospermum. That's a really common one that we see in New England, and it's filamentous. It has the heterocyst and the akinete, so this is where those type of structures are going to be really helpful to identify. And then it has the gas vesicles. This is a bloom former cyanobacteria, and it can also create those really bad taste and odor compounds that affect water quality. Aphanizomenon, that's another one. This one looks more like a strand of hairs when you see it under the microscope. This is another common one that we see in New England. It is filamentous. It has the heterocyst and akinete too. It's a bloom-forming cyanobacteria. Again, it has the gas vesicles, and it really likes high temperatures. And also it creates the taste and odor compounds too. Microcystis, it's another really common one that we see in New England. This is right now the one that has the most thresholds when it comes to the CDC, the World Health Organization, EPA. They all have a threshold for how many cell counts, microcystis, you find in your water, before you start putting an advisory and stuff like that. So this is a well-studied genera, but it's also because it's very common, and it's most likely producing toxins. So that's why we care about this one. They used to be the Annie, Fanny, Mike, so sort of kind of like remember these 3 species, but now Annie is dolichospermum, so it's Anabina, Aphanizomenon, and Microcystis. That's just kind of like an easy way to remember those big 3 ones that we care about. So what exactly is a bloom? And most of the times you know what a bloom is when you see it, but a lot of times you can see clear water, and there could be a bloom underneath the surface. So that could be in the thermocline, or it can be all throughout the water column. So a bloom is an increase of cyanobacterial biomass. A lot of the times that biomass is on the surface, and that gets pushed away by the wind, and then you get like a scum on by a shore or something like that. But also there could be a lot of cyanobacterial biomass just across the entire water column or in just one layer of the pond or lake. They normally develop between a couple days to a couple of weeks, and then it could be a single or multiple species. And then it could be visible, and sometimes it cannot be visible. So their blooms are different, but we're going to go through that so that you learn what to look for. And another thing to note is that algae blooms are different than cyanobacteria blooms. Algae blooms can cause that green scum on the top of the lake or pond too, but when it's green algae blooms, we're not worried about toxins. So there's a big difference there. They can still be a nuisance. They can still make the water look horrible and all that, but it's the presence of toxins that we are really concerned about with cyanobacteria blooms. Let me see. So the non-bloom formers, those are the Picocyanos. Those are like the really small, less than 2 microns cyanobacteria. And those ones are often widely spread throughout the water column. So those, with this kind of blooms, you probably wouldn't be able to see a bloom. So it doesn't form that surface scum. But it's very important to know that they're there because there's a lot of research going into this, but they apparently are very easy to volatilize. So they can be on air particles. And that's a huge problem for people that live around the lakes. It can create like a chronic exposure to cyanobacteria and the toxins that they produce. So this is just a picture of a typical bloom with a lot of the green, like a lot of biomass right on the surface.
Is that an algae or a cyanobacteria?
That's a cyanobacteria bloom, yeah. So how do the blooms form? And this is specifically for the ones that are on the surface of the pond. So they are throughout the photic zone, and the photic zone is the layer of the pond or lake where the light penetrates. So that's the area where light is going to be available for all these organisms to take in the light and photosynthesize. So they grow in this photic zone. And one thing about cyanobacteria is that they can control their buoyancy. So they can go up and down depending on how sunny it is, how cloudy. So they're really well adapted to change their position based on what they need. So it gets warm, so we go into like late spring, summer, temperatures, water temperatures start increasing. Cyanobacteria like it really, really warm, warmer than green algae. So when there's that increase in temperature, that's when they're going to start outcompeting the green algae. And because they're bacteria, they can increase in cell numbers faster than green algae. So they can have as many as 3 cell divisions per day. So warming is a big part of what drives cyanobacteria blooms, like warm water temperatures. Another one is stratification. A lot of the times in summer, we get layers in the lake. So there's a warm layer on the top and a cold, dense layer on the bottom. So that, again, that's going to make it even better for cyanobacteria to thrive in that warm top layer. And then the other one, which is a big one, we have a lot of nutrients. And then the fact that the bottom part gets anoxic or close to being anoxic, that starts releasing nutrients into the pond, into the top layer of the pond, and that again is just feeding the cyanobacteria growth. Then we have, which is really common here, we have either storms or a lot of wind action that affects the cyanobacteria buoyancy. And then it makes it all come to like to the top, to the surface. So that is accumulating something that was throughout this layer. It's now kind of like more concentrated now on the top of the lake. And then we get some wind action pushing it to the shore. And now it's even more concentrated. So it's kind of like concentrating more cells and the potential for concentrating more toxins too. That's why sometimes we see this. This is an aerial view of a pond. This is provided by the University of New Hampshire. This is just where you see the purple, that's higher cell counts versus the blue. So you can see that you don't have a bloom all throughout the pond or lake. The wind has really pushed it so that it's in that corner mostly, but you also see a little bit of other pockets. So that is important to know, especially when you're setting your monitoring program, because you want to know where are you seeing these blooms so that when you're monitoring, you're capturing them. So if you can have multiple sites where you're monitoring that same pond, that's ideal. But I know that's kind of hard depending on how many people are available for monitoring and so on. But that's something that we can talk about. Let's see, what is this? So going back to what is driving these cyanobacteria blooms. As I mentioned, cyanobacteria are they are part of the natural community. It's not like they're an invasive species or anything. They have been here for a very long time. They play a very key role in the ecosystem. The problem is when we have that excess of biomass and they become blooms. And that is driven mainly because of warm temperatures and also increase in precipitation. So a lot of, when we have more precipitation, there's more stormwater runoff going into our ponds. There's a lot of more kind of like things disturbing the lake, affecting that buoyancy. And so this map shows that, especially in the northeast, precipitation is increasing, and this is 71% compared to the rest of the U.S. So we're going to have more frequent storms. So that's going to increase the chance for cyanobacteria blooms. And then the other part is temperature. As you can see this is from the early 1900s to 2010. You can see the increase of, this is air temperature? Yeah, this is air temperature, but you know, it's increasing water temperature. So cyanobacteria like really warm water, with high nutrients, which are going to be, storms are going to increase the nutrient load into our ponds and lakes. So this is an example of a pond. These are all like talking about other drivers of what causes cyanobacteria blooms. Another part is what we do, for example, affecting the hydrology of the ponds and lakes, and also nutrient runoff from agricultural or even just regular development, septic system tanks and stuff like that. So this is an example of Montpesat Pond, and you can see that there's two sides of it, and there's a road dividing this. And on this corner, oh yeah, these are the drivers: climate change, nutrient loads, warmer waters, and we're specifically talking about low flushing rates. In this corner, there is a cranberry bog that when after they're done with their cranberries, they flood the cranberry bog, and then all the nutrients go out into the pond. And then you can see the effect of it. So you can see the difference between the fact that the water is flushing from this side to this side. The water is really not going anywhere here, and the increase of nutrients going into that pond is like really causing a pretty bad cyanobacteria bloom. Yeah.
What is the life cycle of the nutrients in a cranberry bog?
Oh, that I don't know.
Like a cranberry bog,
Mhm.
inactive 20 years, we still need to worry about the nutrient outflow from that.
Yeah, yeah, and that's why there's a lot of restoration projects for cranberry bogs.
So what
Restoration projects for cranberry. Yeah, Yeah, because there's this thing called legacy nutrients that once you add so many nutrients to a system, even you stop adding them, they stay there. The sediment has them. So yeah, it continues to be a problem. But I don't know if I haven't worked with cranberry bogs. I just know of that.
What town was that pond? That's okay.
I want to say Plymouth, but I'm not entirely sure. Yeah, right? So this was adapted from the Wisconsin DNR, and this is just to show the effect of development. So here we have no development, and this blue, green, and brown arrows are runoff volume, phosphorus inputs, and sediment inputs. So this is no development. This is what we call sort of like a mild development, you know, like a cabin, and you still see a lot of vegetation between the building and the pond, and there's a lot of native species. But just by having development there, you see an increase of 4 times higher sediment inputs. If you go into what we consider like high development, where you see that there really is no buffer between what is the building and the pond, you see a huge increase in sediment inputs, in phosphorus inputs, and in runoff volume. So there are many different things that you can do to help the pond and water quality in the pond. And this is from New Jersey. And they just have, there's a lot of resources out there, but this is just sort of like an example of what you can do to green your waterfront. And having more native species, having a lot of vegetation that can take up those nutrients, that can prevent erosion, that can hold on to that sediment, that's going to benefit and help the water quality in your pond. So what we called all of this is watershed dehydration or ecological arrhythmia, where there's multiple drivers that are causing the water quality in the ponds to be to continue to decline. So now going into specifically why do we care so much about cyanobacteria blooms. And the main problem with cyanobacteria blooms, other than, you know, they can be a nuisance because the water is green, it smells bad, and it could taste bad. The main problem is that they cause cyanotoxins. And the hard thing with cyanobacteria is that one genera can produce multiple toxins. So it's really important to know what is in your, if you have a bloom, what kind of dominant species or genera you're seeing, because they could be producing these toxins. But it's also important to understand that just because you have an abena and you have it tested for saxitoxin, that doesn't mean that all the other ones are not being produced. So it's a complicated issue. This is just an example of like all the different genera that produce the different toxins. And then this is just to show you how toxic those toxins are. So these are the lethal doses, oral lethal doses of a lot of the kind of like poisons that we consider to be really bad, like cyanide. So, and you can see that the cyanotoxins are pretty bad. They have a really it takes less of cyanotoxins sometimes to have a lethal effect. Again, cyanobacteria have always been here, and this is fossil records of they found a lot of dinosaurs fossils around what it looks like a watering hole, and the hypothesis is that it probably was a cyanobacteria bloom that caused all those deaths. You know, and then this is kind of like, that was a long time ago. This was 2 years ago or something like that, in 2019, and that's in Botswana. They found that there was like around 300 elephants that mysteriously died right next to a watering hole. And they did a lot of like studies and to see what was happening, because like all the other animals that were drinking water from that area were not dying, so it was just the elephants. So the idea or the hypothesis is that it's because the elephants, when they're drinking from the water. They're not drinking from the surface, but because of the trunk, they're drinking from the bottom. And that could be a cyanobacteria that's like more on the benthic of those watering holes. So cyanotoxin targets, they can be neurotoxins, they can be hepatotoxins, they could be dermatoxins. So again, the toxins are a complicated issue, and they can affect multiple parts of the body. Routes and types of exposure. A lot of it is dermal. So if you go swimming, you might get a rash, or have like some itchiness. And those symptoms occur within hours of direct exposure. Ingestion is a big one. And then that's the most common with pets. So you take your dog for a walk at the beach, and this happened in one of the trainings that we did. This picture from one of those trainings. There was a sort of like a scum, and the dog ate it. Luckily, the dog was fine, so nothing happened to the dog, but that kind of brought that like warning. You know, kind of like everybody got freaked out about it, and they started getting more worried about what their dogs are exposed to. And another way of dogs being affected is that they can go swimming in the water, and then they come out and they're licking their fur and then ingesting the cyanobacteria. So it's important to, if they do go swimming, to wash them or to hose them down so that they don't have the cyanobacteria in their fur. And then another one is drinking water, cooking, drinking water and cooking and recreation. So in many other quality problems, you see these boiling water advisories. That will not help with cyanobacteria, because if you boil the water, that's just going to lyse the cells, and the toxins are going to come out into the water. So the boiling the water does not remove the toxins. It just makes them come out of the cell, and they're still in the water. Yeah, with ingestion is usually hepatic, and can be lethal in some cases. And there are some other cyanobacteria that if they're ingested, they could have cyanotoxins that are neurotoxins. And then another, a big one, it's inhalation. There's a lot of research going into this. That's what I mentioned about cyanobacteria that could go into air particles, and then if you live around a lake or a pond, then you could have chronic exposure to breathing in these cyanobacteria particles. And then I'll pass it on to, yeah. Okay. Well, so no, it's, yeah, that's the hard thing with cyanobacteria blooms. Most likely, if you don't see a bloom, you are fine. But then there is that, that's why monitoring is so important, because you really want to know what's in the water. But yeah, it comes down to your sort of kind of like your risk assessment. So the temperature makes it, it drives cyanobacteria blooms, but right, and the temperature helps it multiply, and they really like the temperature. But that doesn't mean that if the water is warm, there's for sure a cyanobacteria bloom. Yeah. So yes.
In ingesting the cyanobacteria, like if you're swimming,
Mm-hmm.
is it cumulative? So if I'm swimming one day and I don't know that there's a bloom, but I'm either eating it or drinking it or swimming through it, and then another couple of days I go again and I still don't know there's a bloom.
Yeah.
Find out, so is it cumulative?
Yeah, it could be cumulative, and that's where the risk comes in for a lot of people that recreate on the water a lot, or they live by the water. because a lot of the cyanotoxins are not like a direct, it's more actually of a chronic exposure, like the hepatotoxins. It just like some of them cause liver failure after a long time of exposure.
I think if you combine with that too, just because a bloom is gone, and let's say, you know, you have a toxin, that's the toxins can't persist past the bloom. That's why typically, you know, it's closed for a couple weeks.
Right. Yeah, that's why advisories often don't get lifted until like maybe 2 weeks after the bloom. So like even if you're not seeing the bloom anymore, there could be still toxins in the water. So that's why they keep the advisories. Yes.
We've seen an increase of waste stripping, which really disturbs the certification. I'm talking about water scheme.
Oh yeah.
Where they sink the valves really deep,
Okay.
and it goes very, very slow, and they create this huge waves that they can serve
Right.
without
Oh.
which causes this enormous on our shoreline. We just end up with this huge wave.
Yeah.
It really damages the property soil. At the end of the wave, the shoreline is still many times
It's pushing everything.
So are you seeing or examining in any way how recreation can affect? I know in other states they're looking at that wave survey and they're clamping down on how people they can see it
For it to.
shoreline. Well, Massachusetts doesn't seem to be doing any of it.
Yeah.
I don't know if you are looking at any kind of thing that human recreation can do.
No, we're not. But that is a very interesting point, and I haven't heard of that. But it is very interesting. And as you said, some states actually are looking into that, and they have. Yes.
I just caution everybody to please keep an open mind and get information before we make any calls, though, because so I'm a big proponent of wake surfing, but I think that there's ways to do it responsibly.
Right.
And one overnight windstorm that we have every 2 weeks here produces thousands of more waves, in one night, and it's natural. So it's not like anything else. It's not something that's immediately to blame.
Yeah. Yeah, and so many states look into like the effect of boating and all of that. So yeah, it is a part. Yeah.
You see the correlation to the topology of every pond in terms of shallowness. I'm assuming shallow water would heat up faster.
Yeah,
So you see
it does.
blooms happening there before anywhere else.
Yeah, normally shallow water will heat up faster, and it also tends to be a little bit more stagnant. So yeah, you would see more blooms there. I mean, I guess every water body is different, but yeah. Yes.
This pond here in my area can reach up to 80 degrees on the summer.
Uh-huh.
And let's assume
that's pretty warm.
when it's really very warm, I swim.
Mhm.
After swim, should I take a shower? Because I come out and I sit on the beach on the sun,
Right.
sun up and all that. So should I take a shower or is it okay just come out and stay on the sun?
Yeah, that again goes back to are there any advisories posted at the time? Do we know if there's any bloom present?
But assume, I'm sorry, but assume there is.
Assuming there is an advisory?
Yeah.
Oh, if it was me, I wouldn't go swimming if there was an advisory. But
yeah. Where my area is very active. The water moves very fast, constantly.
Okay.
I'm downstream, not upstream, so.
Yeah, and that it does affect where you are in the lake because it sometimes, and that's why it's important to know your system so that you know where normally, things tend to accumulate, where the wind tends to push things. So again, it goes back to your own risk assessment. And I always just kind of like say, the more you know, the better. That's why monitoring is super important, and then you can make your own decisions.
Definitely wouldn't hurt, so.
Yeah, it wouldn't hurt to rinse off. That's true. Yeah. Yes.
The home of the stone that you referenced,
Mhm.
is that this particular
bacteria or can it be any bacteria?
That could be green algae too. So yeah, just because you see a scum on the surface, that doesn't necessarily mean that it's cyanobacteria. And even if it's cyanobacteria, that doesn't necessarily mean that it's toxic. But again, going back to like, you want to be more cautious than, take a risk. So taking a sample, looking at what it is, having it tested, that would be the risk. Yeah.
Also read that the cyanobacteria, if you can swirl a stick and it looks like swirling paint,
Yes.
that's the cyanobacteria. If you can pick it up with a stick,
Right.
it's not.
Yeah, we have what we call the jar and stick test, which is that if you have a stick and then it comes up, like if you just pass it through the bloom and it comes up on the stick, it's probably not cyanobacteria. If you can pull it out and there's nothing on the stick, it's most likely cyanobacteria. And then also if you have a jar, you collect water, you let it sit for like around 30 minutes or more. If it sinks, it's not cyanobacteria, that's green algae. If it stays on the top, that is most likely cyanobacteria because they control their buoyancy. So we're going to talk about that later on. Maura will show you. This is sort of like a cyanobacteria concentrator, and it works on that principle. So she'll talk about that later on. Yes?
Have you also seen where it can be possibly pollen, especially if it's coming
Yeah.
in before? Okay, I
Yeah.
have a picture, the one you showed earlier where the water was just pure green.
And it could be pollen.
Yeah.
Yeah.
Like that. But that was like 5 years ago before we started seeing.
Yeah.
Okay. So
Yeah, that's.
It's so hard to tell.
It is. It is, and like it could be. Yeah. Yeah, it could be pollen. It could be green algae. So yeah, it's important to know what's in your water. Yeah.
But on evaluation of trouble constantly, the phosphates with nitrates and the cyanobacteria, do they have any relationship? Does one feed off of another, or do they?
With the nutrients? Oh yeah, yeah. The more cyanobacteria, they can, a lot of the species, or generally, they can fix nitrogen from the atmosphere. So phosphorus is really necessary for them, more than nitrogen. But also nitrogen kind of helps their growth. So when you have increase of nutrient loading into your water system, you're going to see more cyanobacteria blooms. So fertilizers, runoff from agriculture, stuff that's leaching out of septic tanks, stuff like that. That's always going to affect it. Joanne?
Hi, I'm Joanne Ramona from the Association of Picocyanos. I wonder if I could just say a little bit about our cyanobacteria.
Yeah, go ahead. Do you want to, where's the microphone?
No, that's all right. No, that's all right.
Can you come up here?
Thank you.
And I don't mean to pull off anything, but I want to mention that APCC has had a Cyanobacteria Monitoring Program for 45 years. We set it up with the assistance of Hillary Smith from the CMC and EPA Region 1. We tested it for 1 or 2 years, and we've been working with UNH scientists Dr. James Heaney and Nancy
Leland.
from Liptech Inc. So we have for the past several years been contracting with towns and organizations to monitor cyanobacteria in ponds on a bi-weekly basis, every 2 weeks from May through October. And that's done under contract and for pay, unfortunately, because it's a lot of effort. What we use is the CMC method that you'll learn about today. 2 methods of the microscopy, the microscopic identification of the cyanobacteria genus, because that matters in helping to estimate how toxic the cyanobacteria bloom is, and we estimate the abundance. And then we also use the third part of the CMC's method, which we'll talk about today, which is the fluorometry.
Yeah, we have them out here, and we're going to have a station on it. So.
Very good.
Yeah.
And we use the fluorometry instead of cell counts, because we found that the fluorometry gives very precise results comments from health agents last year. What we added is that Barnstable County is partnering with us. Barnstable County Department of Health and the Environment, their lab is going to be partnering with us, and they're going to be doing cyanobacteria toxin analysis on samples that we determine fall into the moderate or high category based on our fluorometry. So when we go out and collect samples on a bi-weekly basis, we'll collect 2 samples, one for our fluorometry and identification, and then the second one will freeze and keep it, and in the event that our results show moderate or high levels according to levels that we're going to be publishing on our website next week, then we'll send those samples to our county lab, and they will analyze it for microsystems. We talked about adding other toxins, but right now, this is the first year the county lab will do the microsystem analysis, provided that APCC does the pre-screening of it. So that's something new, and so that this year we're doing the double sample collection on our own at our own cost. That's included in the cost of what we charge for the analysis and for the contract. I just want to mention that because that's kind of a refinement on what we've had been doing before. In past years, we had been doing the identification and the fluorometry and getting to a certain point to estimate the amount of cyanobacteria based on the phycocyanin. You'll learn about all that. So this year, by adding the toxin testing option, if the numbers are high enough, that helps to it incorporates the Massachusetts Department of Public Health guidance limits for microtoxin in or cyanobacteria toxin in recreational water. So it's sort of taking 2 different approaches, one of which is the states, which sort of emphasizes the toxin concentration, and which is the CMC method and a scientifically based method, which is the fluorometry analysis and improved systems. So I just want to give a shout out for that.
I got a question for you. Are you a little bit more transparent in your reporting? Because last year, I could never find test results of your reports on your website.
Thank you for raising that point, and I'll take it back to our project manager. We've discussed that. We will have, I think our solution is that we'll have the option of providing the detailed test results if asked. Otherwise, what people had been getting last year was sort of a summary, weekly or bi-weekly of the results. And I hear what you're saying. You want to see the actual numbers.
Because when you do an E. coli bacteria test, they have a limit where it's dangerous to the public, but at least it gives you a count of what was tested.
Okay, I'll take that back to our project manager, and we've had that you're the second person, and we'll provide a way to provide the raw data, probably in an Excel data sheet. Okay.
Does APCC test Schumann Pond?
Yes.
And so
We don't test everywhere around Schumann Pond. We're limited. Generally, the number of sampling points is 1 to 2 points, depending on what we're paid for. It's a very intensive process. The interns and staff go out in the morning, collect the samples, bring it back, analyze it in the afternoon, and by the evening, we have the results, and we post it on our interactive website now. But the Schumann Pond is one of the ones, I don't recall if it has one spot, one sampling location, or multiple. But that's something else.
Thank you so much, Joanne. Thank you.
Thank you.
Quick point, please. I'm new to this. This is
there's a lot of jargon. You know, a lot of acronyms anyway. Like APCC, I don't know.
Oh, that's the Association for the Safety of the nonprofit organization.
Oh, okay, but
Yeah.
you know what I mean, we're moving from county to state to local,
Yeah.
and if you could tell me, you know, what the acronym stands for.
Yes. Cyanobacteria Monitoring Collaborative, we often call it the CMC, so that's that one.
I thought it was the.
How often do they test these ponds around it? Is it the state or is it the town or is it different test the state in the town? How does it work and how often?
It's mostly left to the town. The state only does,
Can I step in?
yeah.
Okay, guys, so there's going to be some information coming out about testing, what sandwich plans to do. The different towns have all met at a state level, all the health departments. And Dave Mason, who is the health department director for Sandwich, and the Department of Natural Resources for Sandwich, and I think also Mashpee, and the rest department director, Guy Boucher. They're going to be putting out 3 different educational videos very, very soon about what was decided at the state level in terms of frequency of testing, what the range is going to be, all of that. So we can kind of table this conversation because we're going to be posting that on our website, and also we'll post it on our Facebook page. So I know there's a ton of questions about what's going to happen this summer and the different ranges and who's doing what. So we'll answer all of those through Dave Mason. You'll get more information about it. I know it's kind of confusing, but kind of like let's shift that over to a little shelf so we can focus on this, so we can finish on time. Is that okay? Okay. Thank you guys so much.
Okay. Hi, everybody. Like I said, I'm Corey Conville. I'm from the EPA lab. And so before we get going, I'm going to talk to you today about the Cyanobacteria Monitoring Collaborative and a little shameless self-promotion here. If you do have any questions or you want some more training resources, I definitely recommend going to our website, which is cyanos.org. I'm going to have it at the end of the presentation too. But a lot of this is going to be there, and we even have any kind of technical documentation. We have a link to our YouTube page where you can find more resources on how to sample and things like that. And a big part of this is it's a 3-tiered system. So we have our BloomWatch app, we have our Cyanoscope, and then we have our Cyano monitoring program. And with each step, you go up in the amount of resources that are needed to participate. So kind of starting at the beginning, which I'm going to talk about the BloomWatch app, is pretty much anybody can participate in this. And then then as you move up to the Cyanoscope, you get a little bit more technical, and then the Cyano monitoring is probably the most involved. But the whole goal of this is to really put the power into your hands for actually the monitoring. You guys are the ones that are on your water bodies. You're there every day. So to be able to participate in this monitoring, I think is really the key, because a lot of times you can call your state, you can call this town, but a lot of times by the time they get out there, the bloom might be gone. So really this kind of puts the power in your hands. So the first thing is the BloomWatch app. And so this is an app that anybody can use from their smartphone. And so as long as you have access to like an iPhone or an Android, some type of smartphone, you can download this app. And what it does is we're crowdsourcing this data from you. If you see a bloom on your water body, you can take a picture. And so I'll pass these around towards the end. We have these QR codes. You can scan it and it should take you right to the download, whether it be for your Android or for your iPhone. And so then you can download that. And so what this does is not only are we crowdsourcing this data, like I said, is coming from the people that are on the actual water bodies, but we also created a real-time alert system. I know you said you created like an email for your group. You can have it set up that people that when they take a picture, they enter that email, and then you'll get those results emailed right to you. And so you're getting this real-time stakeholder notification. You're getting the real-time notification to your town's water body or your states, anybody like that. So this app is an EPA approved app, and within the app, this is the home screen. And so not only is it the system for taking the pictures and things like that, but it also gives you some training information, what to look for, links to our training videos. We're really always kind of working to improve this app. So not only our latest version is now also available in English and Spanish. So, we're really trying to make it more accessible for everybody to use. And so what it does is we're collecting these, we have, the system is set up to have you take 3 pictures. And that is because, like we say, picture's worth 1,000 words. And so you really kind of get an idea then of, the first one you're taking is you're really far away. You're getting an idea of the extent of the bloom. And then it's going to ask you in kind of, there's a drop-down menu for, how big would you say this bloom is? Is it the size of a football field? Is it the size of a car? Is it washed up on shore? And then kind of the next picture that it's going to prompt you to do is take one a little bit closer. And then the last one, so you go a little bit closer, 3 to 5 feet away, something like that. And it's just so then we get an idea of, is this kind of, how widespread is it? What does it look like? And so you said about pollen. This will give us an idea of, it's all washed up on shore and it's yellow. It's probably pollen. And so, but then as you work closer, then you can also do either a really close-up picture from shore or the jar test. Like Shafton said, you can take a scoop sample, let it sit, and then take another picture. And so you can see the one on the right here, I almost said left, but that would probably be green algae because it sank. But the one on the other side that floats, that is most likely cyanobacteria because, as Shaston said, they have those, they're able to regulate their buoyancy. So what they do is they'll actually move up and down within that water column. So something that's going to float like that, probably cyanobacteria. And so once you take these pictures and you send them off, where does it go? And we've created this public-facing dashboard. And so you can go on, and if you're even curious about your water body, that, has there been blooms reported? You can go onto here, you can zoom in on a map to your water body, and then you can see if there's been blooms submitted. And you can get an idea then of, we have, not only do we have blooms reported, but also we have people, doing submissions of no blooms. And that is sometimes just as important as a bloom, because then we can get an idea of kind of, when are these blooms starting to come around? Are we seeing blooms on water bodies that never saw blooms before, or is this kind of like a chronically blooming water body that isn't seeing a bloom this year, which is just as good as as a bloom as well? Because the cyanobacteria, yes, they've been around a long time, but there's such a lack of data on it that really we're always learning. And and by putting the power into your hands to take these pictures and document it, it's really going to help us overall then kind of get an idea of the seasonality of these blooms and things like that. And so one question that we've been getting a lot lately, and so we've added this to our dashboard is, well, I submitted it, and how are you going through these pictures, and what are they, and this and that and the other thing. So we've actually started to, we've added a new feature to the dashboard, which is this pie chart there, and you can see that we're going through and evaluating these pictures. And so Hillary Snook, he's our expert in the Cyanobacteria Monitoring Collaborative, will go through and say, yeah, you know what, this is pollen. So then we can actually get an idea of, oh, this isn't a bloom, or this is most likely a bloom, or a suspected bloom. Or even there's some that we are confirming as a bloom because they might have been paired with toxicity data. So that's all great, but it doesn't tell you what your species is, and it doesn't tell you kind of what is your kind of dominant genre, or it doesn't even tell you if it's toxic. So that's kind of the most basic level, which is great because in my opinion, it puts it out there for the people that are on the lake. And so then you can get a picture, and if you call your Department of Health, and by the time together the bloom's gone, you at least have it documented. So it's really kind of helping on that end. The next end is the cyanoscope. So we have these kits that we develop that they're available for purchase, I think, from a third-party vendor. We do some kind of loans with them and things like that, but it kind of gives you a overall kind of way to sample. So Maura's going to walk you through a lot of the sampling equipment, and Shaston's going to go through how to actually, prep your slides and then identify the cyanobacteria. But some of it kind of gives you everything you would need to collect the bloom sample. So bottles for doing grab samples. We have a plankton tow net, which is tossed out into the water body and then retrieved back, and it'll collect cyanobacteria that are on the top. And then an integrated tube sampler. So this is dropped down on the weight end, and then you're using it then to collect, you put your thumb over the top, and you're being able to collect a sample from the entire photic zone. So this is about 3 meters long. You could also use like a garden hose, or even if you're sampling somewhere that's really shallow, you can cut it to length. It is kind of whatever is going to be the most helpful for you guys. So this is, and then you take those samples. Once you get them in the bottle, you'll then mount a slide and then be able to take a picture or look at them underneath the microscope to see what's there. And then from there, so this is just a quick refresher. Probably been a while since some people were in science classes. And this is just the parts of the
microscope. So you have your coarse focus, your fine focus, and then the ocular lens is a 10x magnification. So you always want to multiply these other ones, the 4, 10, and 40 by 10. And that's how you'll get your overall magnification. And that's important because once you take those pictures, oh, sorry. This is just a little plug for our training videos. You can, everything here, you can always find this on our YouTube page and on our cyanos.org website. And it'll walk you through how to, the intro to the microscope, the calibration, things like that, and also an intro to the cyanobacteria sampling kit as well. So, and then from there, though, once you take those pictures and you mount the slide, we have them uploaded then to iNaturalist. And on iNaturalist, which is like an online, kind of similar to the Bloomwatch, where this is crowdsourced data, this is uploads from people like you out on your water bodies, you can find not only observations, but also training resources. So you can find, any kind of guides to, if you're seeing something you're not sure what it is, you can, look at it through there. Do you have a question? Oh, sorry. Okay. No. Yeah. If anybody has any questions, feel free to stop me. It's whatever. So like this, you can see, there are some examples of blooms on there, so a little bit of ideas what to look for. And then on here, once you take the picture using your slide and you upload it to iNaturalist, it'll tell you what you think it might be, but then also then on a monthly basis, like a panel of experts goes through and they'll go through whatever needs identification and try to give it their best shot as to the lowest level of identification that they can get it to. Like I said, you can see there's a lot of training resources on there. For this is considered what is known as like the dirty dozen. So these are like the 12 most common cyanobacteria that you might see within your water body. So this is kind of taking it a little bit even further than the Bloomwatch. You're getting an idea of the dominant species which you're seeing in your water body, which is great. And then so once it's uploaded, then it's really tough to see, but it's a map. And that gives you an idea then of, if you're uploading it, somebody else is doing it, you can get an idea of, if you're seeing a consistent microcystin bloom or things like that throughout your system on a year-to-year basis as well. And also gives you that confirmation then as to like what the species is. So and so then, like I said, this, you can actually then go in and you can search through and see, reported observations within each water body, and then tracks the GPS data as well. So then we're going to move into the cyano monitoring end of this, and so this is more of the fluorometry. So this is definitely a more in-depth look at what is in your water body. So plants and algae, they all have chlorophyll, and that emit and absorb light at a certain wavelength. But cyanobacteria have phycocyanin, and that'll emit and absorb light at different wavelengths than chlorophyll. And so that's specific to that. So using these handheld fluorometers, you can take a sample and actually be able to test it for it. So kind of it gives you an idea of, instead of having to take a sample and look at it underneath a microscope and, kind of take a shot at it, like whether it's cyanobacteria or not, you're not a taxonomist, it won't tell you what exactly the species is, but if you see your phycocyanin really raising within that fluorometry, you know that there is cyanobacteria within your system. And so this is great on multiple levels because it's pretty easy, as compared to doing any kind of taxonomy. But you can then also, I know the Association for Preservation of Cape Cod, you were able to do a regression model pairing that was it with cell counts? Or tox data?
It's linked to toxicity. So
okay.
Nancy Whelan has developed curves that relate phycocyanin levels to different toxins.
Yes. So yeah. So once you get an idea of kind of the base level of the fluorometry within your system, you can start to track then kind of the lead up to a bloom. And so one thing that you can do here is, by pairing this with, either cell counts or tox data and things like that, you're going to get a more whole view of your water body. And so you can even then get an idea of, you see your fluorometry increasing, your fluorometric readings increasing, you can maybe even start to forecast a bloom and things like that. So again, another plug for our Bloomwatch app. again, that's probably our easiest way for, tracking blooms and really kind of, like you said, you live on the water, you can take a picture whenever you're down there, whether it's a bloom or no bloom, things like that. And if you have any more, if you need any more information, feel free to visit our cyanos.org website. We have a listserv there, so you can keep you up to date on any of our webinars and things like that. But yeah, if any questions, I think that's, if not, we'll start to work our stations, things like that. Yeah.
Testing spirometry, you still have to take the sample to this device, right?
Yes.
As opposed to an in situ thing where it's actually done in the water.
Yes. So kind of similar to you would use the kit for the sampling, and you would then like a grab sample or even the integrated tube sample, and then you would dispense the water into a cuvette here, and then it goes into the fluorometer, and then you'll get your reading from there. Yes. Yes, they're available they're through a third-party vendor. They're for purchase. Yes.
If you go to the cyanos.org website under, sorry? I don't know the website. Like, yeah, you have to call the vendor. We're trying to make it so that it just click a button and we can get it. And we've been trying to get that. Yes, about $800. Yes. But that's not including the barometer. The barometer is...
They are. No, go ahead. They're more expensive.
Yeah, the barometer are like 1,300?
I think so, yeah.
You're trying to go on top now.
Yes. Yeah. And once you have the kit, though, the cyanoscope kit, there's things that you'll have to buy, like microscope slides and stuff like that, but that is really not expensive.
Yeah, once you have the kit, it definitely is a lot easier for monitoring. It's kind of like a upfront cost, but
yeah. It'll last for years.
Exactly, yeah. We've had ours for a long time.
Does the testing that the APCC does on the Schumann Pond get transferred to you?
So a lot of the submissions, it's anyway, like the Bloom Watch, that is through us. Like we have, like that's our dashboard. But any kind of work that your toxicity testing, that has nothing to do with what we're doing at the lab. So.
The question too, about you mentioned about the photic zone of the water. If you have a really clear pond, which this is, and say your photic zone is, I don't know, 15 feet, does that give more of a playground for this to play in, and therefore more likely to have a higher concentration of cyanobacteria?
Yeah, probably. Yeah. It's just, so this is cut to 3 meters because that's the typical photic zone. But, obviously if you have something that's much more clear, it could be, 4 or 5, whatever. It's, yeah. So the best way to take a look at that though would be if you could get like a temperature measurement, and because it's stratified. So typically they would be in that top warmest area because that's where like we said, they can outcompete the greens and things like that. They really kind of prefer that warmer water temperature.
Does anything eat cyanobacteria?
I think there are some types of zooplankton that'll help break it down and things like that. That's kind of why after that 2-week period, after a bloom, because there's types of, I think bacteria that'll help break down the toxins and things like that. So there are, other organisms, and things like that, because it's just kind of, for them with the bloom, it's just getting the right conditions to bloom. But then eventually, they don't last forever like that. So.
Solar. What are your thoughts about solar bees?
What about what?
Solar bees.
I'm not familiar. Oh, yeah. So I work mostly with monitoring, but I know there's a ton of questions about treatment and things like that. And I know on our Cyanos website we have some videos and talks and things like that about treatment.
Yeah, we just had a forum with a really very thorough forum with all the different types of controls and managements for cyanobacteria. So if you want to watch that video, it's on the YouTube channel, so you can access that to the cyanos.org. They went through like, floating wetlands
Yes.
to alum and copper treatments to the solar beams circulated. So like they explain, the advantages and disadvantages of every control treatment. Because they're going to be different for every water body. Every water body is very different. And
So cyanobacteria need sunlight to flourish. Has anybody tried blacking out the sun?
there are some.
You put some.
Yeah, there's stuff in LA where they have this like balls. They're like black balls.
Yeah. Yeah, they'll flip them out.
Cyanobacteria, that's for another thing, but they have thought about that for cyanobacteria. But if you have a natural system, like it's not only cyanobacteria that is using sunlight. So it's one of those things that you can't really. It's like you don't want to mess more with.
Any other questions?
Thank you, Corey. Now so now we can divide in groups of seven. So if you want to